Hey everyone, welcome back to On the Brink. This is Ria from Castle Island Ventures. In this episode, I had the chance to chat with Robert Miller, who is a steward at Flashbots, to illuminate the dark forest created by MEV or a maximal extractable value. We talk about the MEV supply chain and how it's evolved post-merge on Ethereum. We cover new challenges and risk vectors that have emerged as a result of the transition and take an in-depth look at the solutions that Flashbots has proposed and implemented at each stage, including the Flashbots Auction, MEV Geth, MEV Boost, the open sourcing of Flashbots Relay and Builder, and more. In the second part of the show, Robert sheds light on Flashbot's latest and most ambitious endeavor, arguably, which is to decentralize block building and address one of the most significant threats to censorship resistance, starting with Ethereum via what they're calling SUAVE, or the single unifying auction for value expression. So with that, I'll turn it over to my conversation with Robert. Welcome to another episode of On the Brink. I'm Ria, and I'm joined today by Robert Miller from Flashbots, which is an organization which aims to reduce the negative externalities and risks posed by MEV. Thrilled to have you on the show, Robert. Before we get into it, tell us a little bit about you. How did you become such an integral voice on the conversation around MEV, and how did that ultimately lead you to Flashbots?
Hey, thank you so much for having me. Really excited for the conversation. Excited to hear your questions about SUAVE and the work that we're doing. I am a steward at Flashbots and I lead our products. How I became an integral voice, I don't know if I would characterize it that way, but I appreciate it. Uh, I think I've always tinkered with things on chain and really been interested in what kind of activity was happening on chain. This naturally led to MEV and 2019, 2020 kind of era, right around the time that Flashbots was getting started and started contributing to their open source code bases as soon as those were available, and joined the team right away. And people know me because I was posting all sorts of the weird things that I was following on chain, and kind of tales from the mempool and MEV, shining a light on the dark forest before it became widely known. I'm still doing that today, sharing all sorts of interesting anecdotes on chain, as well as trying to advocate for, open, permissionless, decentralized MEV marketplaces. Yeah, so I think that's a little bit about me, how I got involved, and how I'm a part of the conversation.
So, to briefly establish a baseline for listeners, what is the dark forest? What is MEV? And then, why is this question around whether MEV is good or bad more nuanced than is typically portrayed?
Yeah, so the dark forest is this meme that came out of a blog post by Dan Robinson and Georgios from Paradigm a few years ago. And at the time, there was a user who had, I think, about $10,000 stuck in a Uniswap pool. And Dan Robinson, as one does, was running support in the Uniswap Discord while this user popped in and kind of let everyone know their issue. And Dan realized that actually this money was recoverable, but the twist was it was recoverable by anyone in the world that would just call a certain function on the Uniswap pool. And the problem with this is that there was theorized to be these predatory bots that were watching the mempool for transactions which people would make, which would gain them money. And the predatory bot could then copy what other people were doing and front run them by paying a higher gas price to land that transaction instead of the original user. And so while Dan could help this person recover their money, he realized that if he did so, he would reveal the existence of this money that could be recovered, and thus get it stolen away from him by these generalized front running bots, which at the time people weren't sure existed or not, but had just kind of theorized the existence of. And the TLDR is Dan and Georgios had tried to throw this bot off by doing things in a more complicated way, and they were unable to. And a generalized front running bot actually stole the money from them and identified the transaction. And so the dark forest is this idea from the three body problem, a work of fiction, that there's this space where merely revealing information gets you totally obliterated. And it's supposed to describe how the Ethereum mempool is an adversarial place where there are bots that are watching and trying to make money out of the transactions that you reveal into the public mempool in any way that they can. So that's kind of where the dark forest meme comes from. It's an interesting story, and like we can talk more about mempool stuff if you want. MEV, or maximal extractable value, it refers to this more broad concept of the value that you can extract from transaction ordering. It was originally miner extractable value, so the value that a miner can make from transaction ordering within a block, and that includes inserting transactions, reordering them, or censoring transactions too. I think MEV is not necessarily good or bad. We should seek to minimize it, but it's just a fact of public blockchains, and it's a fact of these open, permissionless financial systems that we are trying to create. So if we want to create a decentralized financial system, you need to incentivize people to take actions within them, jobs to be done, like moving prices on pools to be in line with market prices, or removing bad debt from lending markets, or moving a game forward in a round. And since we want these systems to be open for anyone and to not have any privileged actors inside of them, the way that you get people to take these actions is by providing permissionless bribes that anyone can access. In DEXs, this is arbitrage profit. It's like taking a piece of collateral in lending markets. And since this permissionless bribe exists and there is value to be made from extracting it, then MEV exists. And how exactly that MEV gets distributed is a result of transaction ordering policies on chains. And we have to contend with this fact somehow. And Flashbots is kind of about the study of the effect of these permissionless bribes on consensus and on users and the broader network health, and trying to make it as user aligned as possible. So MEV is not good or bad. It's a fact of life, and we have to deal with it.
So can you walk us through, pre-merge and proof of work Ethereum, how different stakeholders were impacted by the existence of MEV, and maybe more specifically, what was the MEV supply or value chain pre-merge in Ethereum proof of work?
Yeah, so I'll start at the beginning of the Flashbots days. So when in early 2020, Flashbots noticed proprietary trading deals that were happening between trading firms and miners that were vertically integrating to give prioritized access to some privileged players over transaction ordering to over others, as well as a increased amount of activity by these priority gas auction bots, who were bots that would try to one-up each other in the public mempool and pay higher transaction fees in order to capture MEV. And in response, we created the Flashbots Auction, which is this side channel that miners could opt into, whereby searchers or arbitrageurs would bid bundles that had specific ordering of transactions to off-chain, and an auction would be run off-chain to decide the ordering of transactions within a block. And only the winners of an auction would be included on chain instead of priority gas auctions, which would have a ton of failed bids landing on chain from these bots in the mempool trying to one up each other constantly. And all those failed bids caused a network congestion because it would use up a bunch of block space that ultimately didn't do anything. It's not going to a productive end, so it just reduces the supply and makes everyone else's block space more expensive to use. And it moved all of this behavior that was otherwise happening in the public mempool into this channeled private auction and freed up more space in the overall network and helped optimize the networking layer as well. So this was the Flashbots auction, this kind of priority side channel that searchers could bid in for an off-chain auction where only the winners were included on-chain, reduced overall gas congestion. We also were able to take these kind of proprietary deals that were happening in a high touch with trading firms and open it up into an open and permissionless marketplace whereby any searcher could bid for inclusion through the Flashbots auction and have access to 95% at the peak of the network's hash rate instead of only one trading firm having access to hash rate. And on the other end, this kept the network more open and democratic because any miner or most miners at the time could have access to the most profitable block instead of miners that had relationships with trading firms or the social reputation in order to get those as well.
Can I pause you here for a sec?
Yes.
I guess what incentivized those different participants, both miners and trading firms, to use this more democratic marketplace or auction mechanism?
So if you were a searcher, previously you were competing in the mempool, and really the dimensions of competition was your view of the network. You had to have this really distributed set of nodes all around the world, so you could have the best view of the mempool possible and respond very quickly, and the latency of your code, because you wanted to constantly be able to re-up and beat out someone else on having the highest gas price transaction at the time that a block was included. But this isn't really what you want to be competing on as a searcher. You want to be finding novel alpha. You want to be finding new arbs. You want to be, extracting novel forms of MEV. And the Flashbots auction, instead, by resolving these things off chain and by kicking only the bid that pays the highest gas price to miners getting included on chain, moves competition more to finding new types of MEV and having the most gas efficient code possible, rather than being really good at priority gas auctions and latency and mempool optimization. So as a searcher, you can focus on gas optimization, finding new forms of alpha. As a miner, you were incentivized to opt into the Flashbots auction because you can make more money that way. Because even if you're a large miner and you had access to some proprietary kind of bundle flow or some deal with a trading firm, you should want to profit switch between that proprietary access that you have and the Flashbots auction and just choose whatever is more profitable. And as a trading firm, even if you could get this proprietary access, you would also want to submit to the Flashbots auction too and access block space that you didn't have access to. So on all sides, parties were kind of incentivized to opt into this more open, permissionless marketplace. Did that make sense?
Got it. Yeah, that's helpful.
You asked a question about the transaction supply chain, and I didn't really answer that question directly.
Yeah, so the question was around the MEV supplier value chain pre-merge in proof of work Ethereum, and then what challenges arose as a result of MEV within that supply chain?
So what did the MEV supply chain look like pre-merge? You had kind of two sources for transactions. You had one, the public mempool. This is public, so nodes all around the world, including miners and mining pools, have access to this. And two, you had this side channel, which was the Flashbots auction. And arbitrageurs or parties who would want to extract MEV, liquidation bots, sandwich bots, NFT bots, all would send these off-chain transactions in what we call bundles to the Flashbots auction that would then be forwarded on to miners through the Flashbots relay. And at the mining pool level, they would run this specialized software to take all the transactions in the public mempool as well as the bundles coming from the Flashbots auction and create the most profitable block possible through kind of a complex optimization problem. And so, really, there, I think you could call it three different parties here. You have searchers, the Flashbots relay or relayer, and miners are the most important there.
Mm-hmm.
You also had users and their wallets. So users would express intents to their wallets that would generate transactions. Most often, these went to the public mempool and got included in the way that I was saying a little bit before. But there were a subset of users who would send their transactions to the Flashbots relay, and those would get forwarded on with bundles in the side channel that I was talking about through our relay to miners. So I think that's what the MEV supply chain looked like in proof of work days.
One thing that you mentioned is this software that allowed miners to take bundles of transactions from searchers
Mm-hmm.
and include them in a block. So talk about that software.
Yeah. So in proof of work, miners largely, there are some small exceptions, but miners largely were creating blocks and ordering transactions within the blocks themselves using specialized software locally. Flashbots put out a client, which was a fork of Geth, which did this on their behalf called MEV Geth. In short, it would run a bunch of parallelized computational work to try to find the optimal ordering of bundles at the top of a block with mempool transactions filling the rest of the block. Just optimizing for like this single constraint of what will pay the miner the most if I include this possible block template. But this is super interesting because we put out this open source software initially, and it was pretty good, but a bunch of miners were starting to improve on that with introducing their own proprietary kind of improvements on it. And if you could introduce proprietary improvements, maybe you could include, 10 bundles where a smaller miner could only include 3. Or maybe you had a slightly different kind of algorithm for how you included bundles, and it produced more profit. And so you even back in the proof of work days had different entities that were competing in effect on optimizing the ordering of transactions within blocks by making these proprietary improvements to the ordering of transactions within a block and improvements to how they optimize that. But one difference, and I'm sure we'll talk about this in a moment, from the proof of stake days is in proof of work, if you were a miner and you were really good at optimizing the ordering of transactions within your block, you had no way of monetizing that by accessing other miners' block space too. You could only really include this optimized set of transactions within your own block space, and there was no way for Ethermine, who was an old miner, to make money off of F2 pools block space, as an example, and we changed that.
Okay, so since you brought it up, let's talk about it. So now we're in a post-merge world, and we've entered this era of proof of stake Ethereum, which has resulted in a new set of risks that requires changes to how blocks are produced, how MEV is captured, and how it's distributed. I think a lot of listeners might have heard our episode with John Charbonneau. And we covered some of this, but maybe for those who haven't heard the episode, and maybe we missed some stuff in that episode, would love for you to review what does the MEV value chain look like now, and then what are the new pockets of risk that exist as a result of this transition to proof of stake.
Yeah, there's a lot to talk about there. So stop me if you want to dig into any part of it. I'm not sure what's most interesting to you.
Okay.
So what does the MEV value chain look like now? I think it's important to maybe go back and talk a little bit about the market structure before and how it differs in proof of stake. So in the proof of work days, we had these large mining pools, and they had a ton of staked capital in effect behind them. You had these huge expenditures on buying mining machines, and we were able to send miners bundle flow, basically because they were staking their reputation, and we could monitor them for bad behavior and threaten to take away bundle flow from them if miners were taking kind of bad actions by front running users, by stealing searchers' MEV or something like that. And that was kind of the enforcement mechanism within the system. But in proof of stake, there are way more staked or stakers than there were miners, and they don't have as much on the line as what mining pools did. So anyone with 32 ETH, coming out of a centralized exchange or another privacy kind of tool, could spin up a validator. And if we want to provide democratized access to MEV, we need some way of giving it to them without those entities being able to see the contents of the block that they're including, because searchers will not want to share really valuable MEV opportunities with a random staker, right? If your MEV opportunity is worth a lot of money, then it's more likely, or there's a decent chance that a small staker or home staker would rather front run that opportunity and take it for themselves. And as a result, you would see centralization by MEV searchers only sending their high value bundles or bundles at all to kind of large entities that are well capitalized, well known, your Coinbase, Kraken, Binance, Lido, Rocket Pool, etc. of the world. So we needed a different design in proof of stake than we did proof of work. And in particular, we needed privacy so that you, as a home staker, could not see the bundles, the contents of blocks before they were included on chain. So this is kind of a starting point for us in thinking about what an MEV marketplace looked like in proof of stake. That informed this new design that we have and how the MEV supply chain has changed. So we get transactions from users and from searchers, and they go to a new set of actors called block builders, who are these specialized actors who are only specializing in creating the most profitable block possible. They're just competing on how do I make the highest payment to a block proposer or a validator possible in this block? How do I merge transactions? How do I offer features that get me to a higher number possible? And block builders send their blocks to relays, who have the job of keeping block builders in check. They simulate block builders' blocks. They see whether the blocks are correct and how much value they pay to validators. Finally, validators will listen to relays for headers of blocks and how much value those headers would pay out to them. So the validator does not actually see the contents of the block. They only get the header and a sense of how much value they would get if they signed that header. And a validator will just profit switch across many different relays, who the relays are aggregating many different builders in order to know which header they should sign. So that's end to end what the MEV supply chain looks like now, and kind of how it differed from the proof of work world and why we made the choices that we did. There are a number of challenges within this structure. So I think the number one, so two challenges are one, it's been relatively surprising the lack of relay diversity within the market. Relays are a super important actor in the system because they choose what blocks end up landing on chain. And without a diversity of relays in the system, you can have subsets of relays that can impose their preferences on a large portion of the market. So if you have certain compliance requirements, as I'm sure everyone knows that we do, then those can inadvertently get imposed on a large percentage of the network, not inadvertently, of course. Number two, we have to deal with builder centralization as well, which again, there are could allow a subset of actors imposing their preferences on the network, as well as extracting rent at the limit if there's one builder that is much better than others. So those are kind of two key risks and issues that we've been addressing since the proof of stake merge happened. Um, a lack of relay diversity within the market and builder centralization more broadly.
So, to summarize, in proof of work Ethereum, because there was this ability to, for lack of a better word, trust miners, you were able to send them bundles of transactions, and they could include any transactions that a potential builder uh, or relay didn't include, and kind of deal with potential censorship uh, from the builder or relay. In proof of stake Ethereum, we've kind of moved to this world where we can no longer scale that trust across a more decentralized set of validators. So now, to preserve the privacy of blocks that builders are sending through relays to proposers and kind of avoid proposers MEV stealing, they're being forwarded full blocks of transactions. But this, if there is censorship at the builder or relay level, there is kind of no way to insert these censored transactions by block proposers. And then simultaneously, while we've managed to kind of decentralize this or optimize for decentralization of validators, now there is this new problem rearing its head, which is the centralization of builders. Is that kind of an accurate characterization of where we're at today?
Yeah, I think it's an accurate characterization. In the proof of work days, you had kind of more collaborative block building, is the way that you could frame it, and you aptly noted this. So both Flashbots, Bloxroute also was a relay in proof of work, and the miner collaborated on a block, and so there was less vectors for censorship. Since the miner could get transactions through the public mempool and they weren't outsourcing the entire block. Today, the entire block, as you noted again, is outsourced to keep the validator set democratized, and economies of scale and block building make us worried that a small number of entities can impose kind of arbitrary rules on blocks, including censorship. There's some other issues in the future too. I think builder centralization is kind of the long term issue. In the short term, you do have relay diversity, also relay centralization, but relay centralization may not be as much of an issue long term because some of the role that relays play will get obviated by including proposer builder separation within the protocol. So it was a very good summary. Yeah.
Okay, so then let's talk about that a little bit because we actually didn't touch on it as much in the episode with John, um, which is going from a world where you have out of protocol PBS to enshrined PBS, which removes the need for an intermediary. Um, but even in that case, the threat of censorship still isn't removed completely. So why is that? And then maybe what are some proposed solutions to that?
So the role that relays are playing within the market is to make sure that blocks are valid and they pay the proposer a certain amount, and then to choose which block to forward on to the validator. And in protocol, PBS is just a way of performing all those functions by the Ethereum protocol itself by like running a committee that will tally up all of the bids from builders and decide which one is the highest bid, and like forcing that to get included on the market and included on chain, and some sort of process for how contents of blocks are revealed too.
Even in that scenario, and I think this is getting us closer to the discussion around why block building needs to be decentralized. But even in that scenario, you're removing the need to trust an intermediary
to facilitate kind of trust between a builder and a proposer, but the threat of censorship still isn't removed completely. So why is that? And then what are some proposed solutions?
Right. So in the proof of work days, there were many more parties that had kind of the ability to create a block. And in proof of stake, we're creating these specialized entities called block builders that are relatively centralized as a group. So something like 5 to 6 entities control 80% of the block building market, and there are 10 different relays, which is much more centralized than the proliferation of miners that existed and the 400,000 different validators that existed also. And these smaller groups of parties can impose their preferences on the network, like censorship, much more consistently than the large distributed network of validators does, which you are seeing from Flashbots today because of what because of the utility functions and the compliance that we have as an entity. But with this said, we think that we've been taking a bunch of actions to prevent this. So Flashbots has open sourced our relay. We did that before the merge. We're encouraging other neutral relays to come to the market. We introduced this feature called min bid. We open sourced our builder to create kind of more competition in the market. And I think as a relative percentage of blocks that are going through the Flashbots relay and that we're censoring, the number will probably start going down. I think it's probably peaked at this point for a few reasons. First, it looks like adoption of MEV Boost has reached a relative peak at somewhere like 90 to 95% of validators. And that last percentage of people are, either running local building for some reason, or they're just not going to adopt MEV Boost. The second thing is more relays are starting to get adoption. So validators who previously were only connected to Flashbots are now connected to other relays that are not censoring. The third thing is that existing relays that are being connected to by more validators are accepting submissions from external builders. So for some time, Flashbots and our relay was the only relay that was accepting external block builders at our relay. And the best builders that exist are Flashbots, Builder 69, this builder called Beaver Build. No one seems to know who they are, but it's a very funny name. ETH Builder. And there's some others on the network too. But all of these folks don't run their own relay. They use the Flashbots relay to access block space, and our relay is censoring, and so the only way that they have access to block space is to go through this censoring relay, and there is no non-censoring avenues for them to get access to block space. But in particular, there's now these two new kind of neutral relays from Ultrasound Money and Gnosis that are accepting external block builders. And I think it's ETH Builder, one of the builders, has started to land a lot more blocks through Bloxroute, which is running a non-censoring relay. So if you've seen the scary charts with like a bunch of red and a bunch of green for the OFAC percentage versus non-OFAC percentage, I think that percentage has probably peaked at this point. In the medium term, there are proposed solutions, what are called CR lists, censorship resistance lists, or inclusion lists, where you give the proposer some say over the contents of the block that a builder has to create for them. So the proposer still doesn't see what the contents of the block are before it's included. But an inclusion list is something like the proposer saying, hey, you need to include these two signed transactions, or whatever you return, whatever you're going to propose to me, I'm not going to include on chain, and it's not valid. And that way a proposer is able to force the inclusion of certain transactions into a builder's block. And the thinking goes that like A more decentralized validator set will be more censorship resistant than a centralized kind of builder set. There's 400,000 validators on Ethereum, and there's much fewer builders. There's some problems with this too, and we can talk about kind of the trade-offs and problems in inclusion lists if you're interested. But we could implement this within MEV Boost, in 2 or 3 months if we wanted. It requires a bunch of work, and it's not just Flashbots' decision, because we would need clients from all around Ethereum to implement changes alongside of us. But if the community is interested, this is like a tool available to us on a relatively short timeline, if we're willing to take the trade-offs. The last thing that I point out is, in the long term, where we want to move is away from this model where there's only one party proposing a block in the block builder role. And instead, you have this more collaborative process of many different parties coming together and creating a full block together. One builder or searcher proposing a small part that gets built on by another builder or searcher who's snowballs into a slightly larger block that's built on someone else. And so you distribute this builder role into many, many, many parties, reducing the ability for any single party to censor transactions or to impose their preferences on the overall network. And this is kind of the long-term research goal that we have, and one of the products that we're going to be building at Flashbots and part of SUAVE too, which we can talk about. So I'd say those are the 3 things we're doing about it. 1, open sourcing and try to induce competition. 2, inclusion lists. And then 3, this kind of collaborative or decentralized block building.
Another thing that I saw that you guys wrote, I think, a research piece about last week, maybe. The piece was called "The Cost of Resilience," and it discussed the introduction of a new feature or parameter that is, would allow proposers to specify like a minimum amount of MEV that a block would have to include for them to accept it from a relay. And if that threshold wasn't reached, then they would kind of default to building it locally. Can you talk a little bit about that as a kind of potential interim solution to this challenge that we're talking about right now?
Yeah. So because of some technical intricacies in how clients work, the way that MEV Boost was implemented is that by running MEV Boost, you are by default just outsourcing all of your blocks to MEV Boost. So regardless of how profitable the block would be compared to a normal mempool block, you choose the MEV Boost block. And this became a problem because Flashbots and the Flashbots relay was adopted to a high percentage of the network. And we are OFAC compatible. And that meant that our kind of legal risk analysis, our utility function, was imposed on a broader set of the network. But at the same time, if you are a solo validator or a staking pool, you then had the choice of foregoing optimized MEV rewards by building locally, which is more censorship resistant, or opting into this kind of censored system by accepting blocks from the Flashbots relay, which is the most profitable one. And this is a non-trivial decision to make too, because there are a couple different times where blocks have been proposed through the Flashbots relay, which are 300, 400, 200 blocks, something like that. So you don't want, and on average, I think the median block or something like that is 100% more valuable than a mempool block on MEV Boost. So it's quite a boost to the median profit, and at the limit, you could make 400 ETH. So you don't want to. It's not in your incentives to turn off MEV Boost and to build locally. But because of technical quirks, there's no way to kind of profit switch across the mempool and MEV Boost, or to say, I only want to opt into this system if it's a really valuable block. And that was this min bid function that you are highlighting that we introduced in our latest MEV Boost kind of release. So now validators can say, hey, I want to accept MEV Boost blocks, but I only want to accept them if they're bidding to me, 0.05 ETH or 1 ETH or 100 or something like that. And everything below that, I'm just going to build locally instead. And local building allows a validator to construct transactions from their mempool, presumably with no rules on transactions that they would censor. So it keeps the network more resilient and involves more parties in kind of the block building process, which is what we want, while allowing them to still optimize for MEV profits and not incur too much of a cost for this resiliency. And if you are smart about it, you can even program this, depending on the proportion of blocks that you want to build locally versus outsource to MEV Boost. So maybe you want to build 50% of your blocks locally and outsource 50% to MEV Boost, and so there's like a concrete number in the blog post that you would need to set your min bid at in order to get to that point. So this is another kind of short-term solution that we had for how we can make the network more resilient while not forcing people to give up a huge amount of potential ETH rewards in order to achieve that.
So this is all great short-term solutions, but still not enough. And, kind of the North Star, as you said, that we need to kind of achieve the censorship resistance guarantees that we're all here for on chain is trustless block building and decentralizing block building. So, you mentioned this a few times already, but last week Flashbots shared details about this much more robust long-term approach in this post titled "The Future of MEV is SUAVE," which really sets out a comprehensive outline for this vision. So let's get into that. What is SUAVE at a high level?
What is SUAVE? A question I've gotten a lot over the last few months. So SUAVE is the single unifying auction for value expression. It is the future of Flashbots and what we think the future of MEV is. It is a decentralized network that unbundles the mempool and the block building role and creates a more decentralized and collaborative process for how blocks are built that is permissionless and censorship resistant. It's also how we plan to address key centralization risks to the builder market, like exclusive order flow and cross-domain MEV, and hopefully address MEV on more domains than just Ethereum, like rollups as an example. So that's it's a very short description. That's light on details. So happy to dig into that anywhere you're interested.
Yeah, let's get into it. So, I think you had this great post. You shared a really great thread, and there's different components of SUAVE that you're bringing together to create this entire system. The preference environment, the execution market, and then the decentralized block building market. So let's unpack each of those one by one.
Yeah. So SUAVE begins with this environment that we call the preference environment that aggregates and surfaces preferences on Ethereum, where Flashbots is a builder today. We have preference. We have the ambition of this being a universal place for preferences too. So not just on Ethereum, but on other domains too. And by preferences, we really mean something that a user wants to happen in the world. So in MEV land, this could be like I have transaction 1 and 2, and I want them included in this order, and I'm willing to pay, X amount for this only on Ethereum. It may be I want to be included at the top of the block, or to be included without front running, as an example. These are kind of more MEV native preferences, but SUAVE is intended to support broader preferences than that. Like I have asset X and I want Y and I'm willing to pay Z. So this is the preference environment is this place where we surface all these preferences, we aggregate them together, and we get a lot of information.
How are these preferences translated to and expressed in SUAVE? And then is there a cost associated with expressing the preferences? And if so, who bears that cost?
Good question. So the way that they are expressed, translated, is by users signing messages that express their goals and that unlock payments if their goals are met. So concretely, there is a SUAVE chain where money is locked up into these bid contracts that program kind of the goals that users have within the world. I want the state to be X or Y, or I want transaction hash Z to be included, and the conditions under which kind of payments would be unlocked. So there's a cost to getting money to this chain and then into these contracts. And once you have borne that upfront cost, there's no cost to signing a message that allows someone to unlock that payment if your preferences or your goals are met. So we envision this environment where it's optimized for this purpose of people being able to express kind of the widest range of preferences possible, not just MEV, not just trading, but all sorts of different types of preferences across many different domains. And we're optimizing this environment for that purpose and for really the purpose of preference expression, execution, and settlement, which is to say to make it as costly and good UX as possible for this. And that's the role of the preference environment and part of the role of this blockchain that we're launching to called SUAVE chain, which is optimized for this purpose. But preferences don't do anything in the world if they're just expressed. You need some way of these preferences getting actioned on. And we envision this marketplace of specialized actors called executors, who their only job is to take preferences from the preference environment and to execute on them and to compete for providing the best execution possible to users on what their preferences are. Again, abstract, but to break it down, as an example, you may have a bunch of users who have preferences on trades that they're interested in making. I have X asset, I want Y. In the execution market, you'd have different executors that are bidding to give them the best trade possible. Or maybe you have order flow auctions that are taking place, and the executor that pays the user the most for their transaction is the one that gets the right to execute on them. So your preferences are first surfaced in the preference environment. They're passed to the execution market where there's competition among executors for executing them. And the output of that is either a single transaction or a list of transactions that are fed into a decentralized network of builders that are collaboratively building a block together. So the output of the execution market is just this input into this kind of chaotic network of many parties collaboratively and progressively building a larger and larger part of a block together until a full block is proposed to the overall network. And that's end-to-end kind of the picture of SUAVE. What do you want to dig in there? Because I'm sure you've got questions.
Yeah, so let's go back to the execution piece. Who are the potential executors in this system?
So we have the ambition or the hubris of wanting to execute on many different types of preferences. So in the abstract, an executor would be anyone who wants to compete on providing best execution for some type of preference. And this is going to differ depending on the preferences that people end up expressing on SUAVE.
And why would someone want to provide best execution? What is the incentive to them to provide best execution?
Because they could get paid for doing that
Okay.
concretely. Yeah. so as an example, like you builders today are executors. Their job is to take searchers bundles, find the most optimal ordering of transactions in a block, and get that included on the network. And if they're really good at it, they can outcompete other builders and take a fee. We're building an order flow auction at Flashbots, which will redistribute value that users create back to users. And you could run this auction and have users pay you a little bit or take a fee from the MEV you're able to redistribute, as an example. So this is an incentivized marketplace and a competitive one at that, where you can get paid for providing jobs, so to speak.
Okay, and then how does that potential rebate occur in practice?
In practice, it depends on the type of order flow auction. I can talk about some of the ideas that we've had at Flashbots, but there's many different types of order flow auctions. So you'll see different parties running different types of executors in order flow auctions. One simple way to do it. It's not what we're doing, but kind of the most simple structure and the easiest to understand is users send the order flow auctioneer their transactions, and they want to auction this off to get paid, for their execution if their transaction creates MEV. So a very simple, naive way to do this would be to strip the signature from a user's transaction, forward that on to a network of searchers, and have searchers respond, hey, here's a transaction that pays the user, X ETH. And the auctioneer then aggregates all these bids, sees which ones pay the user the most, and chooses the highest paying bid to send onto the network with the user's transaction that has a signature, as an example. We're not sure whether this works. We think that there's some problems with the ability to enforce that and with the leakage of information, but I think that's the simplest order flow auction to understand, maybe.
One thing that you talk about is you need certain features within this network to actually build out all of these functionalities: the preference environment, the execution market, the block building market. What features are necessary to kind of build these different components, and how are you planning on offering these features on SUAVE out of the gate?
So the preference environment, the execution market, and the decentralized block building network are really ways of describing kind of logical components of the architecture of SUAVE and different jobs that SUAVE needs to get done. So on one, it needs to surface as many preferences as possible within the preference environment. Two, it needs to minimize MEV by providing the best execution to users possible given their preferences. So you're minimizing MEV. And then three, it needs to maximize MEV by finding the optimal ordering of transactions in a block given the output of the execution market. So that's where these different logical components and features come from. But this is kind of a very broad and abstract way of thinking about things with much modularity, because we have the ambition and the need to address problems in many places across crypto. And so we have to adapt for different environments, right? So to kind of address cross-domain MEV, you can't just build things for Ethereum. You have to build them for rollups, as an example, and super high low latency chains and non-EVM chains and centralized exchanges probably also. Which is to say that these components are very modular and very broad and adaptable. And it's more of a framework for thinking about the architecture than each of these is like one concrete product. The way that we are approaching that is by thinking about the immediate market needs that exist within crypto and how to keep the broader MEV marketplace on Ethereum healthy, and trying to take what we think would do that in the short term and link it up to the broader long-term vision of SUAVE in these three different parts. So concretely, what that has been working on these short-term kind of changes to MEV Boost, inducing more competition in the builder market, the relay market, min bid, inclusion list research, etc., and creating a executor in the execution market with an order flow auction that redistributes value back to users. We have a different design that we'll be talking about in public soon, from what I shared earlier.
Mm-hmm.
And that's kind of the first step here where we're starting. While we do R&D and research on collaborative and decentralized block building, we think we'll learn a lot from the OFA process in that, and get the preference environment kind of ready and think more about how we work with the community to address MEV, not just on Ethereum, but all of crypto, all rollups, all of their chains also. So that's a little bit how I think about the features and different components and kind of the approach that we're taking in building this and where we're starting and why, if that addressed your question.
Going back to the preference environment, and this question is kind of relates to the fact that SUAVE wants to be a network for the expression of preferences and decentralizing block building across chains. Is it possible to standardize the expression of preferences across different ecosystems, or is that kind of still an area of research that you don't really have all of the answers to?
I mean, probably. So at the limit, like in a bunch of different chains, what really matters for MEV is transaction ordering, or at least like ordering after a certain piece of state. And so all you really need to express is like, I want this transaction hash included at this spot, either behind another transaction hash or, the first transaction hash included after a piece of state is equal to a certain thing. So we think you can standardize that, and we'll be launching with a couple examples of how you could express your preferences in that way, and then it's a matter of kind of scaling SUAVE in the preference environment to be able to read data from a bunch of different places, I think. But you're always going to have kind of nuances to this and different ways in which these preferences are executed. So you can standardize, this transaction execution for a good amount of places, but of course not everything. I don't think there's ever going to be kind of universal standards. As an example, if you have an L1 where you have super, super low block times and super cheap block space, the dominant MEV strategy is actually to spam the chain and to do your MEV search on chain instead of off chain. So you have a smart contract where you're trying to find ARBs, as an example. You're doing all of that within your smart contract. And since it's super, super, super cheap, you just hit the chain as hard as you can over and over, running that MEV search until probabilistically one time you find an ARB. And that one ARB that you find is going to pay for, 10 million failed transactions or something like that. And if you have a preference of extracting MEV on a chain where spam is the dominant kind of model, then you're not thinking in terms of transaction hashes anymore, because you don't have kind of the latency in order to have that abstraction. You're thinking in terms of spam. And in that world, your preference is something more like, I want to pay someone every time my contract successfully executes. And the natural incentive is for an external party to spam your contract, and such that they get paid upon a successful execution. So it's a long-winded way of saying, like, I think there's probably a good deal of standardization, but you're always going to have kind of some differences depending on the dominant MEV extraction strategies, if that makes sense.
Just switching gears a little bit, I think one thing that was
highlighted by you guys is the importance of having privacy for different stakeholders in this ecosystem, right? So, how do you offer privacy while allowing these different parties to do their job in the SUAVE ecosystem?
It's a really good question. So privacy is really important for a few reasons, which is not what you asked, but one, to prevent censorship, two, to induce maximal competition, three, to prevent things like front running and MEV stealing. And how you achieve privacy is still kind of to be determined. Right now, privacy is achieved by just trusting Flashbots. Searchers and users trust us not to screw around with their bundles, and of course, we don't. This is suboptimal for a bunch of different reasons, like what we've been talking about today, where Flashbots can impose our preferences on the network and censor transactions. We want to scale to be able to allow parties that are less trusted than Flashbots to be able to run these kind of entities also, and introduce privacy. In the short term, we think that the most viable way of doing this is by using secure enclaves. It's like Intel SGX, where you're running a piece of hardware where even the party that has access to the hardware can't see what's going on inside of that hardware. You don't have access to the contents inside. And there's all sorts of problems with SGX, and we can talk about it. But this is the most viable way to add some level of privacy with reasonable efficiency in, say, the next 3 to 6 months, if we want to distribute the market away from Flashbots and to add privacy even from Flashbots. In the medium term, we're super excited about multi-party computation and the prospect of using actual hard crypto to do this. And in the long term, MPC or fully homomorphic encryption or some even more magical forms of crypto are also kind of exciting. But none of the pure crypto solutions are ready, and we don't think that they're going to be ready in, say, the next year or two. And the only thing that seems to be ready to go would be kind of secure hardware solutions. So that's what we're going to use for privacy in the very short term, and move away to pure crypto as soon as we can.
SUAVE is launching or will launch as like a standalone chain. Does that require any kind of bridging layers between networks that connect to SUAVE for any of these activities, or will different chains that plug into this network be able to plug into SUAVE trustlessly?
So kind of as a principle here, we're trying to make this as easy for validators as possible, making it simple for a validator on ETH to plug into SUAVE. And functionally what that means is that all validators need to do is to continue to listen to MEV Boost in the marketplace, as they do today. We expect that to be similar on other chains also, and it's the job of executors to handle the inclusion of preferences as opposed to the validator. And the validator is just listening to transactions in whatever way they get them, whether that's the mempool, whether that's MEV Boost, or some other way. The burden instead is put on searchers, who are highly sophisticated, highly motivated entities that can make money, and executors who are similar in kind of scope of searchers to get some money on SUAVE if they need it. Sometimes you won't need it on SUAVE chain, and to use SUAVE chain if you need to. You do need to bridge over some value. So there will be a bridge, at least starting on ETH, where if you're expressing your preferences on SUAVE for execution, you'll need to bridge some ETH, lock it into a contract, express your preferences in the way I was saying earlier. But trying to make it as easy for validators and users as possible as a principle.
So I know you guys just put this out and, you want to build this in the open with anyone and everyone that wants to contribute. But do you kind of have an ideal timeline in mind? Do you feel like, you know, you need to get this out as soon as possible? And as you're building this out, is there any risk that like centralized block building prevails and it just becomes really hard to transition to this decentralized system?
It's a really good question. So I don't feel great that Flashbots runs centralized infrastructure that has as much influence in the network as it does. On one hand, I'm proud of our team and the products we made. On the other, it does place a lot of trust in us. And we have had negative impacts on the overall network, in addition to the positive ones, like we were saying earlier, of course. And I want to move to a world where Flashbots is much more decentralized as soon as we can. So, really, the answer to your question is yes, as soon as possible, please. But these are super hard problems, and this is a super ambitious vision that we're building. And even building this for Ethereum will be very hard, let alone addressing these challenges for all of crypto too, which is our eventual kind of ambition, because you need to do that to address cross-domain MEV. I hope to have kind of the end-to-end picture working in some frame, which is to say the preference environment all the way to some basic decentralized block building. Of course, in enclaves, most likely, where the block building is happening collaboratively across many different entities instead of just one centralized, AWS server. I hope to have that at some point in 2023, along with the order flow auction. And that'll be kind of the MVP end-to-end process of SUAVE, which will be relatively inefficient. It'll be using secure enclaves, which like you hold your nose and accept that it's the best trade-off in the short term. Mm-hmm. And we will iterate from there and probably only, at least Flashbots running this infrastructure for Ethereum first, while we figure out some of the open problems, while we figure out how to make it more efficient, while we work with partners to scale this to other places also. So that's kind of how I'm thinking about timelines. There are risks here, Ria, and it's an important question. I want to get to the system as soon as possible because the market could still centralize in many ways. So to come back to those two key builder centralization risks of exclusive order flow and cross-domain MEV, I'm a little worried looking at the market structure today that builders are already engaging in exclusive order flow deals where like a wallet or an application is only sending their transactions to a single builder and not other builders. And this gives them an advantage over other builders and can, create these kind of flywheel effects. This is not the crypto that we want. This is not open. It's not permissionless. It's like high touch social deals between builders and another one. And it kind of defeats the purpose too, because you generally engage in an exclusive order flow deal because a builder will kick you back some MEV rewards. You think your users will get better execution. But if you take this to its natural conclusion, you just get one single dominant builder, and that one single dominant builder can extract rent from users and from validators, which is the kind of business model of an exclusive order flow builder. So we're worried about exclusive order flow. We don't think it's in the interests of wallets or users. We want open, permissionless, competitive marketplaces, and we think that's what's going to drive the most value to users too. And I do worry about that, and it is a fire under us to ship SUAVE as soon as we can, and hopefully a fire under everybody listening to this podcast to come and build this system with us.
You guys hammered home both in the announcement and a lot of the Q&A is that you want to be very aligned with Ethereum and the native asset of SUAVE, and correct me if I'm wrong in that terminology, will be Ether. So talk a little bit more about that and maybe the role that Ether will play in the SUAVE ecosystem and network.
We are Ethereum aligned. We love Ethereum's ideals, what it stands for, what its vision is, the world that it wants to bring in. We love its community and its decentralization. It's the roots of Flashbots, and it's what we want to build on and to preserve. We are extremely mindful of the privileged role that Flashbots has within this ecosystem and how, if the wrong incentives are introduced into SUAVE and to Flashbots even today, it could kind of corrupt the incentives of the validator set and have negative effects on it. It could have a centralizing effect on the validator set of Ethereum. And so we're being very careful of the incentives that we introduce into the system. We're being very careful to be ETH aligned at every step of the way. And a core part of that is using ETH as the token for SUAVE. So if you are paying for gas fees on SUAVE chain, you're going to need to bridge ETH over to SUAVE chain for that, which means that there's no SUAVE token. And we're thinking that the validator set for SUAVE chain also should be a reflection of the validator set on ETH. So it kind of reflects the relative distribution of power on ETH and its validator set back. And we're not introducing any extra protocol incentives that way as well. Mm-hmm. The last thing that I'll say on this note, and it's something we're asked quite a bit, is about Flashbots monetization and sustainability, because it's related to a token, it's related to alignment, it's related to our business models. And in the long term, Flashbots does want to be sustainable. We would like to think we're good actors, and we have this ambitious kind of roadmap of things that we think need to happen in order to preserve the decentralization of crypto and to bring a whole lot of good benefits that MEV could bring to the world. But to do that, you need to make money and be sustainable. With this said, we think that the current market structure of MEV today is not sustainable, and it is broken because of the censorship that exists, because of the effects of cross-domain MEV and exclusive order flow. And so we're super hesitant to monetize in some way until we have a market structure that we feel better about, and until we've solved these problems of exclusive order flow, cross-domain MEV, censorship resistance. And once we get over those, and once we start to address those problems, then we can think a little bit more about monetization, and it'll be more clear that we're not accidentally introducing some incentives that are misaligned with ETH and the networks that we are serving.
As this SUAVE network emerges, will Flashbots itself perform some of these functions of being an executor or, participating in decentralized block building?
The kind of playbook for Flashbots historically has been to stand up these new marketplaces and to bootstrap them to make sure that they are competitive and efficient. But this is the scope of our ambitions in creating these marketplaces, to design them and make them competitive and efficient instead of being a participant. And that's how we approach this in SUAVE too. We do intend to be an executor. We do intend to be a builder, as we do today. But it is not our ultimate goal to monetize, these individual roles that we have. We want to be the neutral marketplace designer, not the participant, and to find some kind of incentive compatible way to be sustainable within that. And those are the ends that we have in running infrastructure within SUAVE.
So we covered a lot, and I'm sure there's a lot more to cover. So I kind of want to take a step back and ask you, what else should we be asking? What are kind of some important questions that you're getting that we didn't cover that you think listeners should be aware of?
I still think exclusive order flow is relatively underpaid attention to by the
Mm-hmm.
majority of people. The effects of sending your transactions to a single builder, the effects of proprietary deals between applications and builders on the overall network. This is one thing we should be asking about. The second thing is how geographic diversity affects the credible neutrality of public blockchains, the relationship between having builders mostly located in certain geographies like the US or the EU, of having the validator sets distributed in one are located in one place and not another, and how that relates to properties that we seem to like censorship resistance. So geographic diversity is something we think about a lot, and I think is relatively understudied.
And I know Flashbots, produces so much research. Has Flashbots, or have you seen any good analyses on both of those?
So exclusive order flow, yes, there are a couple good posts by a researcher called Quintus on our Flashbots forum. So if you go to collective.flashbots.net and you search exclusive order flow, you'll find them. Geographic diversity, no. You are gonna have to go look at Phil Diane's Twitter threads, and he had a good podcast on Epicenter not too long ago about this. But there's no research that we put out on that. I think the last thing is just generally privacy in the context of MEV is relatively underexplored. So there's some trade-offs that you make with privacy. On one hand, you want privacy because you don't want parties to front run you or give you worse outcomes. On the other hand, it's much more difficult to optimize for MEV if you have full privacy. In particular, if we have these systems that can pay users back MEV that their transactions create, you actually don't want full privacy. There's some middle place in this frontier of full privacy and no privacy that is the most efficient point on this curve, that seems optimal intuitively. So this kind of way of thinking about privacy we call programmable privacy at Flashbots, and this frontier of privacy and efficiency I think is relatively underexplored. I can keep on going on, but I'll stop myself there with those three things.
Well, I've kept you for way above our allotted time, so I'll ask my last question. How can people stay abreast of what you're working on, and how can they get involved?
So how can you stay abreast? Bert C. Miller on Twitter is my Twitter, and then I follow all members of Flashbots. So you can go to my 30 following and follow all of us. We don't have a Twitter account. We don't have a newsletter, anything like that. So you're gonna have to just follow us on Twitter to get information for what's going on at Flashbots. And we have a forum, so collective.flashbots.net. All sorts of discussion around MEV, about the future of MEV research, SUAVE, what we're doing today. Would love to see more people on there posting and getting involved and contributing. So I think that's the best places to stay in date and best places to get involved.
Great. Thank you so much, Robert. This was awesome, super comprehensive. I'm sure there will be a lot of threads to pull at from this conversation that I'd love to continue to explore on our podcast, but really, really appreciate all your time.